Example number 2 asks us to find the slope of the graph of f of x equals square root of x at the point where x is equal to 1. So a few things that we'll start off with here is slope. Slope of the graph at a point means that at a single point, this is a tangent line that they're looking for. So tangent line equals derivative. So slope of tangent line, I should clarify that. Slope of tangent line equals the derivative. And for now, because we don't have the rules yet for derivatives, we're going to ask that you practice a little bit with the definition of the derivative. So I'm going to write out the definition. Limit as h approaches 0 of f of x plus h minus f of x all over h. So we begin with taking my highlighter, I'm going to circle f of x plus h. So that's going to look like, when I write out my problem, limit as h goes to 0, x plus h is the input into my function. So now I have square root of x plus h. And then in a different colored highlighter, I'm going to circle the minus f of x. And that is going to be recorded as minus square root of x in the problem all over h. So now when you plug in and do direct substitution, which you'll do enough of these problems to where you find that the initial substitution doesn't really result in anything that would lead us to a conclusion. In fact, you get 0 over 0, which we'll call an indeterminate form. You can't tell what the answer is. So what we then do is think of all of the analytical ways that we learn to simplify a limit. And in this case, since we have radicals, even when the radical's on top, what we're going to do is rationalize. And rationalizing is multiplying the top and the bottom by the conjugate. So in the case of the numerator having the radicals in it, we're going to multiply the numerator by square root of x plus h. And what makes it the conjugate is, remember that sign change. The negative becomes a positive. Square root of x all over, we multiply top and bottom by the same thing. And then from here, the reason why we do that is so that we can distribute. So x plus h to x plus h, square root of x plus h to square root of x, and then double distribute the square root of x to the square root of x plus h and the square root of x to the square root of x. So let's go ahead and finish off the problem here. So we have limit as h goes to 0. Square root of x plus h times itself is just x plus h. Square root of x plus h times square root of x is, they're both inside square roots, so we're going to write them inside the square root as x times x plus h. And then now what we're going to do is distribute square root of x to the binomial on the right. So we end up with negative times a positive is negative. So minus square root of x times x plus h inside the square root. So we'll notice that when we do things like this with the difference quotients, we'll see things start to cancel out. And then negative times a positive is negative, negative x. Then all over h, and we'll leave the h there for now because I can't see what could possibly simplify from distributing it. And then let's cancel out things that we notice are opposites of each other on top. And then, in fact, the x and the negative x cancels out as well. And we end up with our solution, or closer to our solution. We have just an h on top, which is wonderful because down at the bottom, we have that h that's on the outside. So that h on the outside is times. So we know that we can cancel those h's out. And so my limit becomes limit as h approaches 0 of 1 over square root of x plus h plus the square root of x. If I plug the 0 in, I end up with, so when I say plug in 0, I'm evaluating the limit by direct substitution. I plug 0 in, I get 1 over square root of x plus square root of x, which is 1 over 2 square root of x. And that is my derivative. And hence, It also represents my slope, so let's write that there. So this is my derivative, it's also the slope, and I didn't finish the question because it says at the point where x is equal to 1. So the slope at x equals 1 would mean that I would plug in 1 into the derivative above, and I get 1 over 2 times square root of 1. So 1/2 is my answer.